Now we will discussing iterators concept. Iterators. Iterator is an object. Iterator is an object that can be iterated upon. That can be iterated upon on top of the iterator object. Iterator object on top of the iterator object. We can apply the iterations. Okay, iterator is an object, like a list is a one object, tuple is a one object, set is a one object. Similarly, iterator is also one object that can be iterated upon. On top of the iterator object, we can apply the iterations. On top of the list object, we can apply the iterations. We can apply the on top of the tuple object, we can apply the iterations. On top of the set object, we can apply the iterations. Same like as a on top of the iterator object also, we can apply the iterations. If we want to create your own iterator object, in that situation, that particular class contains two types of methods. If we want to create iterator object of any class, that class should contains under next methods should contains dunder next methods collectively these two methods are called iterative protocol. If we want to create iterator object of any class, that class should contains dunder iter method and dunder next methods. We can get the iterator object. We can get the iterator object by calling iter function. We can get the iterator object of any class object object by calling iter function. Next one, we can get the one by one element. If we want to get the R, we can get the one by one element from the iterator object by calling next function. Whenever we are calling iter function, internally this method is invoking. Whenever you are calling next function, internally this method is invoking. If no more elements in our iterator object, we can call still we can call next function to raise the assertion error. Raise the assertion error. Write a program to create iterator object on built-in iterable object like list object. Now here I am taken as a one list object. Okay, this is my list object, print of x and print of type of x. Type of x. Now observing very clearly. Now that is a list object. Now I want to create iterator object of this particular list class object. Y equal to, by calling iter function, iter of x, print of y, print of type of y. Now observing very clearly, whenever we are calling iter function, internally one method is invoking. That method name is called done return. Already x is a one which class? List class. List is a one built-in iterable object. Now observing very clearly, dir of list. Okay, in that list class, one method is available. That method is called dunder iter. Whenever we are calling iter function, internally this method logic is executed. After that one, whenever we are creating iterator object, now observing very clearly dir of y, print of dir of y. In that iterator object, one method is there. That method name is called next. Whenever it is invoking, whenever we are calling next function, that means print of next of y. Now we are getting one element from our iterator object. One element from one iterator object. One more time we are calling, we will get the another iterator object next of y. Whenever we are calling one more time, print of next of y. Next one more time I am calling print of next of y. If no more elements, still we can call next function print of next of y to raise the stop iteration exception. To raise the stop iteration exception. To raise the stop iteration exception. Now observing very clearly. to raise the stop iteration exception. We handle we handle handle the stop iteration stop iteration exception. We handle the stop iteration exception by using for loop. Now observing very clearly how working for loop internally or internal execution of for loop. This is the procedure. Okay, how to take the next element internally. This next function related logic is already implemented in the for loop. Simply we are using for I in y print of I. Okay, same procedure we are getting same result. Okay, whenever we are using for loop, how to take the one by one element from our given iterable object internally, next function is executed. Internally, next function is executed. Okay, here I am creating to create a iterator object on built-in iterable object like list object. My requirement is write a program to create iterator object on our own class object, our own class object. Now I am taking as a one class power2 under init one constructor. I am using a self comma m value self dot m equal to m. Next one def under iter self dot n value is 0, return self. Def next under next if self dot n less than or equal to self dot m. Now I want to print one value, observing very clearly result equal to self dot n power 2. Next one, I want to update the n value. Next one, return result, else block is stop iteration exception, stop iteration exception. Now I am creating my own class object p equal to power 2. This is my own class. At the time of creating a power 2 class object, the constructor will be executed. In that constructor, one attribute is there, that is a m attribute. Now I'm passing m value is 4. Now I want to create iterator object to our own class object. How to creating iterator object? I equal to iter function of p. Now I is a iterator object. Now, if you want to make one object or if you want to generate one element from the particular iterator object, simply next function we are calling next of y. My requirement, that result I want to print it. Now print of next of I. One element we are generated. Next one more time, I am calling next function next of I. That means initially n value is 0, max value is 4, 0 less than or equal to 4, result equal to 0 power 2. 0 power 2 means result value is 0. N value is updated 1. Whenever we are calling next time, now n value is 1, 1 less than or equal to 4, condition is true, result equal to 1 power 2, 1. Now return the result 1, n value is updated. Now, one more time we are calling next function print of next of I. Now n value is 2, 2 less than or equal to 4, condition is true, result equal to 2 power 2, 2 power 2 means 4. One more time we are calling next function print of next of I. Next of I. Now observing very clearly, 3 less than or equal to 4, condition is true, result equal to 3 power 2, 9. One more time we are calling print of next of I. Now 4 less than or equal to 4, result equal to 4 power 2. 4 power 2 means 16. Next one, n value is updated. Again, one more time, I am calling next function. If no more elements, that means 5 less than or equal to 4, condition is fail. Control go to else block to raise the stop iteration exception. Please try to understanding this one. Okay, we can handle this stop iteration exceptions in scenarios we are using simply for loop. But whenever we are using for loop, internally what will be happen, this procedure will be done. In the internally, we are executed next function. That for loop inside next concept and stop iteration exception, how to handle this exception, this procedures already implemented in the for loop. That's why we are using for loop. That is a very, very easy process. But whenever we are using iterators concept, it is providing the user friendly. Whenever we are calling the iterator object, how to get the one by one element internally, what will be happen, everything it is providing clearly. We are calling next function, next function, next function. Now same example I am explaining by using for loop. For I print of J. Same result we are getting. Here internally next function logic is implemented, and internally to handle the stop iteration exception. These all techniques are already internally implemented. Okay, this is the for loop advantage in Python. Don't comparing other languages. This is the iterators concept. Next one, generators.
So what is the use of this iterator? Already we have for loop, and which is already well defined, right?
Okay, if you want to create your own iterable object, like as a list format object, tuple format objects, if you want to creating by using this concept. Okay, list is already built in iterable object. If you want to make your own iterable objects simply by using this iterator concept.
Okay. But still not clear, sir. I'm sorry, but I don't know.
This is a normal class object. If you
Yeah.
want to create iterator object simply by using iter function, already list is a one iterable object that contains group of elements. Tuple is also one built-in iterable object. It is contains group of elements. If you want to make same like the type of your own objects, that objects are built-in objects. If you want to create your own class object, the type of object simply by using iter function.
Okay.
Okay, P is a normal class object. We cannot performing any iterations on this particular P.
Yes. Yeah.
If you want to create your own object, later we can apply the some iterations on that particular object. Simply we can make that object as a iterator object.
Okay.
How to create your own iterator object? Simply by using iter function. Whenever we are calling this iter function, internally one method is invoking. That method name is called this method.
So that
Okay.
means if you want to create any iterable object that can be created using class object, right?
Yeah, class. Same iterator object. If you want to create by using functions, that concept is nothing but a generators.
Okay.
Okay.
Now got it, sir. Thank you.
Next one, generator. The generators are used to, or before that one, a generator is a function. Generator is a function, which contains one or yield statements. The generator is a function. Which contains one or more yield statements. The yield statement is also same like as a return statement in a normal function. The yield statement is also same like as a the yield statement is also same like as a return statement in a normal functions. The yield statement is also same like as a return statement in a normal function. But what is the difference between this yield statement and normal return statement? Now observing very clearly, once control reach the return statement, our function execution will be terminated. Once control reach the return statement, which one? Our function execution is terminated. But whenever control reach the yield statement, our function execution is not terminated. Later we can continue remaining statements in our function. That is the difference between return statement and yield statement. Now observing very clearly, I am explaining. For suppose here I am defining one function f1. Some statements are available. Here, this is a return statement. A return statement. By mistakenly, after return statement, I am written some statements. These are the statements outside the function, above the function definition. This function is a return statement. This function is a normal function. Okay, same function I am defining one more time. Def f2 yield statement now observing very clearly. This is a one function. Next, observing very clearly. Whenever we are executing this program, these statements are executed. Control will go to the statement. This is a which statement? Function definition. It is not executed, then immediately control will go to this one. This is a which statement? Function calling. Then immediately control will go to function definition. Now our function body logic is executed. Now this is the return statement. This is the return statement. Once control reach the return statement, once control reach the return statement, then immediately control will go to function body. Then immediately control will go to this outside the function. That means our function execution is terminated. By mistakenly after return statement, we are written any statements. These statements are not executed. That's why in the normal functions, we can representing the return statement must be last statement. The return statement must be last statement. Coming to the generator function, first these statements are executed. Control will go to this one. This is a function definition. Then immediately control will go to this one. This is a function calling f2. F2. Next one, then immediately control will go to function definition. Now function body logic is executed. Now this is a yield statement. Whenever control reach the yield statement, don't terminating our function execution. Later we can continue the remaining statements. Later we can continue the remaining statements in our function. If no more statements, then only control will go to function outside the function. That is the difference between these two functions. This is a normal function, this is a generator function. Any function which contains one or more yield statement, that is called a generator function. Are you clear? Return statement, that is a normal function. Yield statement is a generator function. Are you clear or not? Please
So this
respond.
yield, if we don't write yield also, then that is treating as same, right, sir? What is purpose of this yield?
Returning a value, return statement and yield statement purpose is same. Any function which contains yield statement, that is called generator function. The purpose of return statement and yield statement is same. What is the purpose of return statement? To return the value. Same yield statement also to return the value. Okay, the
So
purpose of
here when you say return the value means the return, I mean whatever the value we want to return from that function, those statements will be written after this yield statement, right?
Okay, here the generator function, once control reach the yield statement, don't terminating immediately. If any statements are there, that statements are also executed after yield statement. But in the return statement, once control reach the return statement, then immediately control will go to outside the function. That's why at the time of discussing normal functions, the return statement always we are represented as a last statement in our function.
Yes.
But yield statement, we can return any position in our function.
Sir, here when we mention return keyword, so we will mention some function name or variable so that it will return some value in the output screen. So what about yield, sir?
Yield same also. Yield we can pass any value, that value will give the output.
But it won't terminate.
Don't terminating, later we can continue the remaining statements.
Okay.
Okay, here
Sir.
passing one value.
Yeah.
Here also we are passing one value, that value is written.
Yeah. Yes, sir, understood. Thank you, sir.
The yield statement is also same like as a return statement in a normal functions. Next one, we can implement the iterators concept. Iterators concept in easy way and simplified manner by using functions instead of classes. The generator function to return the generator object. The generator function to return the generator object. Next one, whenever we are calling generator function or next function, whenever we are calling next function, the generator function will be executed. The generator function is executed up to yield statement. Whenever we are calling next function, the generator function is executed up to yield statement. There is no There is no yield statements. There is no yield statement. There is no yield statement in our generator function. In our generator function. In our generator function, there is no yield statements in our generator function. Still we can call next function raise stop iteration exception. Stop iteration exception. There is no yield statement in our generator function. Still we can call next function to raise stop iteration exception. To raise stop iteration exception. Now print board and taken as a high. I am defining one function f1. Here n value is 0. Print hello yield n value is updated n plus equal to 1. Your next one yield n value is updated. Good morning. Good morning. Yield n value is updated n plus equal to 1. Print how are you? Now whenever in our function some return statement is there, how to handle that return statement? Simply one variable assignment. Same like as a here also one variable assignment we are using a equal to f1. Now a is a generator object. A is a generator object. If you interest, print of a and the print of type of a. Now that is a generator function. The generator function to give the output as a generator object. Next one, if you want to execute the generator function step by step by calling next function. Print of next of a. Now our generator function is executed up to yield statement. That means up to these statements are executed. N value 0, print hello, and n value 0 is printed. N value 0 is printed. One more time we are calling print of next of a up to another yield statement. So Krishna, and one message is printed. Print of next of a. Observing very clearly n value 2 good morning message is printed. Good morning 2 message is printed. Next one more time we are calling next function. There is no yield statement. Simply after executing the yield statement, what are the remaining statements? N value is updated. How are you message is printed. After printing how are you message, now to raise the stop iteration exception. To raise the stop iteration exception. To raise the stop iteration exception. Now observing very clearly. We can handle this as stop iteration exception simply by using for loop. Simply by using for loop. I in A, print of I, print of I. Are you clear? This is the generators concept. Next one, closures. Closures. A closure is a function. A closure is a function. Comma. We can treat. We can treat. We can treat any function as a closure function. As a closure function, we can treat any function as a closure function. We can treat any function as a closure function. That function follow should follow. A closure is a function. We can treat any function as a closure function. That function should follow some rules. Some rules. Rule number one. The function must be defined as a function must be defined as a nested function. The function must be defined as a nested function. That means function inside a function is required. Function inside function is required. Next one, rule number two. The inner function must return a value. That value, the inner function returning a value. That value is defined in the outer function. The inner function must return a value. That value is defined in the outer function. Next one, the outer function must return a inner function. The inner function must refer to a value. That value is defined in the outer function. outer or enclosing function. Outer or enclosing function, that is another name of outer function. Inner function or nested function. Any function which follow these three rules, that function is nothing but a closure function. The function must be defined as a nested function. The inner function must refer to a value. That value is defined in the outer or enclosing function. Next rule number 3, the outer function must return a inner or nested function. Now observing very clearly, I am defining one function f1. Here I am taking as one parameter x. Now I am defining one more function f2. Now observing very clearly, that is the rule number 1. The function must be defined as a nested function. Okay. Function inside function. This function is called outer or enclosing. This is a nested or inner. Or meaningfully inner and outer function. No problem. Next rule number 3, 2. The inner function must refer to a value that is defined in the outer function or enclosing function. Simply I am using print x. Before that one, here print I am using next one. The outer function return the outer function return the inner function f2. Now a equal to f1, a calling print by statement. Whenever executing this f1, we are passing the x value, one string object I am passing. Now observing very clearly, this type of functions we are calling as a closure functions. Rule number 1, the function must be defined as a nested function. The function must be defined as a nested function. That means a function inside another function. That means here I am defining f1 inside f2 function. Rule number 2. What is the rule number 2? The inner function must refer to a value. The inner function must refer to a value that is defined in the enclosing function. That is defined in the enclosing function. Next rule number 3. The outer function or enclosing function to return the inner function. To return the inner function f2. Are you clear this one? Control go to the statement. This is a f1 definition. Then immediately control will go to this one. Now f1 calling. Control go to function definition. F1. This value is passing to x. Now x contains Shiv Krishna. Next control will go to this one. Now this is a function definition f2. Then immediately control will go to outside the f2 definition. Now this is a returning statement. That is a return statement. Which statement? In the f1 body return statement, this return statement is related to f1. Whenever control reach the return statement, our function execution is over. This return value will be storing into a. Now what is the return value? Our return value is F2. That means this result will be storing into this particular object. Now A means internally it is contains F2. It is contain F2. Next one, whenever control go to the statement, whenever control will go to the statement, A calling. That means internally we are calling which one? F2 calling. Then immediately control will go to F2 definition. Now F2 body logic is executed. Hi message is printed. X value Shiva Krishna message is printed. Next one, good morning message is printed. Good morning message is printed. Now function execution is over. Control will go to here. This by statement is executed. Now this is the output. Are you clear? If anybody any doubt, please clarify your doubt. Are you clear or not?
Yes.
Okay, whenever we are understanding this concept, then immediately we are understanding easily decorators concept. We are not understanding this concept, we are not understanding decorators concept. Same, it is like as a decorator also. Just the difference is F1 takes the parameter as a one more function. That is the different only.
So here we are calling a function, right? I mean, how it is going to F2, sir? Can you execute and show me?
Here A means A contains internally F2.
Okay.
Yeah, we are calling F2 internally. A calling means F2 we are calling.
But we defined that A as object of that function 1, right?
That object contains F2. F1, what is the return of F1? F1 return F2.
Yes.
A storing the result of F1. What is the result of F1? F2.
Yes, sir. See, when we create this A object, it already returning F2. Why we are calling again A?
Whenever we are calling A, then only F2 function is executed. That is a function.
Can you run it and show me, sir, once?
This is the output. Okay.
Okay, good morning is coming. Shiva Krishna is passing.
Okay, whenever we are calling A, then only this function logic is executed.
Okay, sir.
Here I am passing which one? Return F2. F2 is a function, not any value. That is a function. Whenever function is executed, whenever we are calling that function, then only that function logic is executed. That's why I'm calling this one.
Okay, the function itself returning, sir.
F1 return F2, not F2 return. F1
Okay.
return F2.
Okay, okay.
This is the statement of F1, not F2.
Yeah, correct, sir. Got it. Yeah. Thank you, sir.
Next one, observing very clearly, decorators. Whenever we are understanding closure, decorator concept is also similar to closure, but difference is that function takes the parameter as another function. That is the only one difference. A decorator is a function. It takes the parameter as another function or method. Decorator is also same like as a closure, but it will takes the input as any function or method or method. Generally, decorator is a function. Decorator is a function. It takes the input as any function or method, comma, to add something to that function or method under returning. Now observing very clearly, I'm explaining one example. After that, we are getting the more clarity. Now observing very clearly. Generally, this is nothing but a which one. Now here F1 is a which one? Closure function. Are you clear?
Yes, sir.
Yeah. Now observing very clearly, same closure function takes the input as any one function or method. Now that closure act as a decorator. Are you clear understanding my point? Previously, at the time of calling F1, we are passing one object, string object or integer or any one object we are passing. Now we are passing either function or method. Are you clear understanding?
Yes, sir.
Yeah, now I am defining one function F3. That one print. So Krishna. Now observing very clearly, I am calling my closure function F1. A equal to F1 of, I am passing the parameter as one more function F3. Here I am calling that X. Now observing very clearly. Okay, this is a which one? Closure function. This closure function takes the parameter as a which one? One more function. Now in that scenario, this function act as a decorator. Are you clear? That is the difference. Any closure function, it takes the input as any function or method. Now that closure function act as a decorator. Are you clear understanding? In the previous example, I am passing one object directly, one string object I am passing, or one integer value or any one thing, one object we are passing. But in this scenario, I am passing the parameter as a which one? Function. Already we will discussing decorator is also same like as a closure. The difference is it takes the input as function or method. Are you clear understanding?
Okay, sir.
Yeah, now I am trying to execute in this program. Control go to this statement. This is a F1 calling statement. Then immediately control will go to this one. This is also which statement? F3. definition, then immediately control will go to this statement. Now this is a which statement? F1 calling statement. Then immediately control will go to F1 definition. Now this F3 is passing to X. That means our X contains, what is the X value? Please try to understanding what is the X value. Function F3. Are you clear? This value is passing to this one. Are you clear understanding? Now F1 function body logic is executed. Now control will go to the statement. This is a F2 definition. Then immediately control will go to outside the F2 definition. Now our F1 function execution is over. Our F1 function to return F2. That result will be storing into this A variable. Now A contain the result of F1. What is the return value of F1? The return value of F1 is F2. That means A contains F2. Now that's why I'm calling A calling. Then immediately control will go to F2 definition internally. Now this logic is executed. Hi message is printed. Now this is a calling statement. X calling means internally we are calling F3. Then immediately control will go to function definition F3 and the function body logic is executed. Now Shiv Krishna message is printed. Next one, after executing the F3 body, then immediately control will go to the next statement of the previous X calling. Now good morning message is printed. After executing the statement, control will go to here. Now by statement is executed. Are you clear? Okay, in the previous example, we are understanding same procedure. Just I am changing one object to function or method. I am passing the input. Here I am passing the input as a function. F3. That is called decorator.
Sir, when I run this program, I'm getting some error like type error, none type object is not callable. Hello?
Yeah, tell me. Just
Sir,
wait. My program is executed.
Yeah, but for me, it's throwing an error and saying the error type is type error, none type object is not callable, and it's showing at line. We are calling a method, right? So that's it. There it's showing error.
Okay, we are calling, or we can defining F3 function or not?
Yes, sir. We are defining.
Yeah, please send your code in chat window.
Yes, sir. Just a minute.
Okay, we are not calling F2 statement. F2 is required. Function name, function, not return the function result.
Okay.
The outer function must return the inner function, not inner function result calling statement. Just function name is required.
Okay. Okay. Got it, sir. That's it. Thank you, sir.
Yeah. Same example, I am using annotations concept. Annotations concept, simply observing very clearly. Already we will discussing class method decorator, static method decorator, abstract method decorator. These are all already defined decorators. Now I want to use my own decorator simply by using annotation. Simply by using annotation, which function or which method we want to take the input as our decorator function, simply at the rate our decorator function we are passing. Our decorator function we are passing, simply we are calling F3. Now same result we are getting. Hi Shiv Krishna, good morning, bye. This is the shortcut, that means annotations. If you want to use the decorators by using at the rate symbol. Okay, which function or which method we want to take the input to our decorator function. Which one? Above the function definition or method definition, simply by using at the rate the decorator name we are passing. Whenever it is activated, whenever control go to this statement, then only it is activated.
It's like, okay.
Same result we are getting without any changes.
Yeah, I think you have explained this like class decorators and static decorators, right, sir?
Yeah, class method decorator, static
Yeah.
method decorator. The decorators are built-in decorators.
Okay.
This is a one user-defined decorator.
Okay. So we can define our own decorator.
Yeah. This is a decorator. If you want to use this decorator anywhere, simply by using this one, which function or which method we want to take the input above that function definition, simply by using at the rate symbol, the decorator name we are using. Okay.
Okay.
For suppose if you want to use this decorator into another program, simply import this model name dot decorator name. Okay.
Yeah. So automatically, whenever we call that F3 function, F1 will also be
Internally,
executed.
yeah, internally that F1 take this F3 function as an input and execute the F1.
Oh, okay.
If you want to make any method as a class method, simply above that method definition, we are using at the rate class method. That means now that class method take this our own method as an input and working as a class method internally. In the class method, some properties are already defining. That is a built-in decorator. Are you clear?
Yes, sir. It's good.
Yeah. Okay, decorator means decorator is a one function. It takes the parameter as any another function or method and executing. Okay. These are the four concepts: iterators, generators, closers, decorators. Are you clear?